7-5, fractional exponents. You're going to need Know It Note page 101 and probably a little bit onto the back side of 102, although I might wait and do that with part 2 tomorrow, actually. Really today, it is very important that you make sure you write down the examples because the definitions are kind of hard to understand. So make sure you especially fill in the numbers part of the definitions and the algebra part so you see the pattern. And then any extra numeric examples we do, you can put those at the bottom of page 101. There shouldn't be any problem filling those in. So we know that the radical symbol, we dealt with those way earlier in the year and you've done them in the past, right, is used to indicate that we're going to take the root of something. And the little number to the left of the radical symbol tells you what root to take. That's called the index. So there's a spot up there at the top of page 101 under the vocabulary to write that down, that the index is the small number to the left of the radical symbol. So when we see that little 3 there, that tells us that we were going to take the cube root. And remember, when we're taking the root, we're looking for what number times itself equals the number underneath the root symbol. What's different today is that we're going to be taking fractional roots instead of whole number roots. Whoa, crazy computer. All right, that's where we started. Okay. So this is where this comes from. Now, you don't have to write this down. I just want you to kind of follow along so that you understand where these fractional exponents, fractional roots come from. So we're going to assume that for b greater than 1, that the square root of b equals b raised to some power. Okay, and that's what this says here. Square root of b equals b to some power. As long as we do the same thing to both sides of an equation, we can do it whatever we want. We could add 20,000 to it, but I don't want to add 20,000. I just want to square both sides. So I'm going to square both sides, right? That's what this little 2 is. And I'm going to see what happens. Well, if I square root something and then square it, I'm just right back to where I started. So that's b to the first power. And if I follow my usual rules, my pen's going kind of crazy here, right? Then I'll get b to the 2k power. K raised to the second power, right, will then be 2k. Since they're both set equal to b, right, I can actually then just say that the exponents are actually equal to each other. So 1 equals 2k, and solve for k. K equals 1/2. So that's where this starts to come from. Now, if you think about that, right, the square root is really like when this has a 2. So think about this pattern. If the square root is b to the 1/2, then the cube root is going to be b to the 1/3 power, and so forth. And that's what we're going to write down next. Well, that's actually what we're almost going to write down next. First, you're going to jot this down somewhere, probably in between the vocab and the key concepts. When b equals 0, any root of 0 is 0. Really, probably even just the text here is good to write down. Okay. And when you take a root of 1, any root of 1, you get 1. So I could take the 10 billionth root of 1, it's still 1, because 1 times 1 times 1 times 1 is always going to be 1. Now we'll write down the property, or the definition, excuse me. So the definition in the box there, right, and I've got it all nicely starred for you so you know what to write down. A number raised to the power of 1 over n is equal to the nth root of that number. So 3 to the 1/2 power is the same thing as the square root of 3. 5 to the 1/4 power is the same thing as the 4th root of 5. Which wouldn't be a whole number, but it's still equal to that. We're going to try to mostly stick with ones that are the answers are integers. And then algebraically, right, write down what's in the purple box here. B to the 1 over n power equals the nth root of b. So b to the 1/2 power equals square root of b. B to the 1/3 power equals the cube root of b. B to the 1/4 power equals the 4th root of b, and so on. Probably need a little more time to write that down, so pause the video and then come back to it when you're done. So this seems complicated at first, but it's actually not as complicated as it sounds. If I'm going to take, for example, 343 to the 1/3 power, I'm going to take the cube root of 343. Now, many of you have calculators where you can do that. If you don't, it's okay. On tests and quizzes for this chapter, I probably won't let you use a calculator because some of you have calculators where you don't have to even think about it. You can just type it in as is and it'll give you the answer. And that's not really what I'm looking for. So we're just going to try and think in our heads right now. Blank, right, times blank would equal 343. Well, it can't be too huge, right? Because, 10 times 10 times 10 is 1,000. And I think it can't be 5 because it has to end, then it would have to end in a 5, right? But let's see, 6 times 6 times 6, well, 36 times 6 is probably a reasonable kind of guess, but it's not going to end in the right digit, right? That's only 216, 216. Wow, that is terrible handwriting. So it's not 6. How about 7? 7 would be 49 times 7, ding, 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 and that's going to be 343. So the cube root of 343 is 7, not 7 times 7 times 7, just 1 7. 32 raised to the 1/5 power plus 9 raised to the 1/2 power. So what this tells me to do is to take the 5th root of 32 plus the 2nd root of 9. Usually on square roots you don't actually write the index number, but you can. Okay, so let's do the 9 part first. That's easy. So that's 3. 5th root of 32. Well, anything I multiply together 5 times and only get 32, it's going to be pretty small. So my guess is 2. 2 times 2 is 4, times 4 makes 16, times 2 makes 32. So the 5th root of 32 is 2, and therefore the whole answer is 5. It's kind of fun. It's like a little puzzle. Let's try another one. Okay, so try C. You should be writing these down. Remember, writing down all the examples at the bottom of the page there. 81 to the 1/4 power. So you're thinking in your head, the 4th root of 81. So what 4 numbers would I multiply together that are all the same that would give me 81? Okay. And hopefully you have sorted through and realized that once again it's going to be pretty small, and it's going to be 3. Okay? Because 3 times 3 times 3 times 3 would be 81. Okay, so that's the 4th root of 81. Try the next one, write it down, pause the video, and then check back in a second. Now that you're back, so we have the square root of 121 plus the 4th root of 256. Well, I know the square root of 121 is 11, plus 4th root of 256, maybe 4? Right, 16 times 16, aha, that is 256. So plus 4 makes 15. And if you get stuck on it, you can use your calculator. I'm not saying you can't use it. Just try to do as much as you can without it, because you won't have that crutch on tests and quizzes. That said, it's not going to be, the 27th root of, some enormous number. They're going to be ones that are pretty familiar. I would say all of these are good candidates. So now we're going to move on. We're going to move on to the second definition, which is what if we have a fraction that doesn't have a 1 on top? That's a little bit trickier. Okay. When you have that, there's really 2 ways to think about it. There's 2 ways to calculate it out. So let's look at option 1 first. You don't have to write this down. Just hang in there with me and listen. Okay. So I can think of b to the 2/3 power as b to the 1/3 power doubled. Okay, and so that's why it's in parentheses here. I've got b to the 1/3 power, and I'm going to go ahead and then double that at the end. B to the 1/3 power can be written as the cube root of b. And then I'm going to take that, because I still had to square it, right? That's what times 2 meant here, where I broke it apart and raised it to that power. So now I would have to square it. So I can take the cube root and then square it. That's one way to think of it. The other way to think of it is kind of turning the fraction around here. Here we have b squared times a third. And we're going to keep the b squared together, and then at the end, take the cube root of it. Now, I happen to like the first option better, because if I'm going to take the cube root of something, it's going to make it smaller, and then I can square it. Whereas if I do the one over here on the right, the first thing I do to my number is I make it really big, and now I have to find a cube root of something that's already really big, which is harder. So I really like this way better. Let's get ready to write that definition down. A number raised to the power of m over n, that's the fraction part, is equal to the nth root of the number raised to the mth power. It's kind of wordy, so take your time, pause the video and write it down. Which means that 8 to the 2/3 power, you can think of it either way. This is the first way I showed it on the left side, right? This was the left, this was the one on the right. Okay, so I can say it's the cube root of 8, then squared, or I can think of it as 8 squared, then cube rooted. The order of the operations actually doesn't matter, so you can always do whichever one seems simpler. And then for the algebra, you can just write down, you don't have to write down all the what's greater than, blah, blah, blah. You can just write down the actual algebra part. So pause the video, get all that written down, then we're going to do a few examples together. Write down the example down there at the bottom, so 81 to the 5/4 power. So my choices are the 4th root of 81 raised to the 5th power, or 81 to the 5th power and then the 4th power. Now, I don't know about you, but I most definitely do not know what 81 to the 5th power is in my head, but I do know what the 4th root of 81 is, especially because I already did it in this lecture a little bit earlier. So the 4th root of 81 is 3. We did that earlier. Okay? And now I'm going to raise 3 to the 5th power. And I might still need a calculator for that, or I might be able to figure it out by hand. Right? Well, it's actually pretty easy because I already know what 3 to the 4th power is. It's 81. Right? So I have 81 times another 3, which is 243. Some of you are kind of savvy. You'll start to see kind of how this works, like whether it's a fraction bigger than 1 or smaller than 1, what's going to happen to your answer. Okay. Now, here's another one. 3,125 to the 2/5 power. So I could either square 3,125 first, or I could take the 5th root of 3,125 and then square my answer. If you're really not sure, you can use a calculator to figure out that 5th root. Use the root button where you're allowed to change the index. If you don't know where that is on your calculator, be sure to ask me. I'll be happy to show you. But I know it has to be something like 5 or 15 because it's ending in a 5. And my guess is it's probably 5 because even though it seems like a pretty big number, it's not when we start multiplying a lot of things together. So 5 times 5 times 5, right, this is 125. Times another 5 is 625. Times another 5, sure enough, 3,125. So this is really just 5 squared, or 25. Okay? So if you think about it, here's 3,125. Right? Take this, expand it, here's what we get. We need 2/5 of that. 1, 2, 3, 4, 5 parts. Take 2 of them. Voila, 25. Right? Start to see how that works? It's a little kind of mental shortcut. One more. Oh no, 2 more. 16 to the 3/4 power. Write it down, pause the video, try it yourself. You're back? Here's what I'm thinking. The 4th root of 16 cubed. The 4th root of 16 has to be 2. 2 cubed is 8. Right? And once again, in the kind of comprehension way of thinking about it, right, we have 4 2s makes my 16. I need 3/4 of them. That would be 2 times 2 times 2, right, which is 8. 1 to the 3/5 power. 1 to anything, and the root of 1, any root of 1, it's always 1, right? It's just always, easy, always. No exceptions to the rule. Okay, and the last one, a little word problem. Write it down, right? Write the formula down, or I'll make it so the other part disappears. V equals S over 6 to the 3/2. That's what you write down. Given a cube with surface area S, the volume of the cube can be found by using the formula V equals S over 6 raised to the 3/2. Find the volume of a cube with surface area of 54 meters squared. Now I could go ahead and simplify this first and then plug in 54, but I don't think that's a good option. Let's plug in the 54 now and simplify as much as we can before we raise it to a power. So 54 over 6 is 9 raised to the 3/2 power. Now this is greater than 1, 3/2, so our number should be bigger than 9 when we're done. So we're going to take the square root of 9, put the index if you like, and then cube it. So the square root of 9 is 3, cubed makes 3 times 3 times 3, which is 27, and the units were meters squared to start with, but now we're in volume, so that would be meters cubed. If you think about it in terms of the way we were writing them out before, 9 is made from 3 times 3. Right? That's 2/2. We need another half, or we need half of that, so that adds that third 3 in. And that's it for part 1. The next part, part 2, is all going to be variables.